This is the webinar for the Waste Packaging and Storage PhD. The webinar is for the NDA Bursary calls for this financial year, and is an annual PhD bursary call, which NDA set aside around £500,000 to fund PhD projects each year, of which there are a number of different categories. The categories NDA will be supporting are characterisation, waste packaging and storage, land quality, decommissioning, spent fuel and nuclear materials. We'll be holding webinars for each category based on last year's feedback. The feedback we got was from the people that were actually judging the applications, and in some cases they weren't always hitting the right spot and aligning with what the needs of the industry are and the things that they were wanting to see out their proposals. Hopefully this will give us a better alignment with the proposals and with our research needs. Also gives you as academics the opportunity to ask the technical experts questions and write better proposals. So the schedule for the webinar is about 20 to 25 minutes of technical presentation, leaving half an hour for questions at the end if we have many questions. If you do think of any questions as we're going through the presentation, you can type them in through the speech bubble that you can see up on the right hand side of the screen. If you just click on there, and then it'll give you the option to type a message in. Questions will then be read out at the end of the presentation, and we'll be able to address them at a time. But please do bear in mind that when you're asking questions, that this is a public forum, and so be respectful of any, if the presenters decide that they don't want to answer the question, or give a redacted answer if they feel the questions are around sensitive subject matters. So I will hand you over to Richard Guppy and Sean Morgan, who will be giving the technical presentation. Richard, if you just want to let me know when you want me to change slides.
Okay. Yeah, I'm Richard Guppy from RWM Limited, Senior Waste Management Specialist, working on waste packaging with the waste producers. So I'm one of the co-chairs of the working group. I don't know whether Sean wants to introduce himself.
Yep, I'm Sean Morgan. I work for the Technical and Engineering Directorate at Sellafield Limited.
Okay, I mean, Sean, do you want to do the first few slides, just the background to the working group, then I can pick up the first few topics after that?
No problems, Richard. Yes, basically, the Waste Packaging and Storage Working Group, as probably most of you are aware or probably guess, is instituted basically to try and encourage coordination and collaboration across the NDA estate with our R&D with respect to waste packaging and storage, obviously. In that role, what we try to do is we basically bring together a three yearly meeting where basically we try to go to either one of the SLC or one of the institute sites and present various different work, and in particular introduce our SLC members to what capability there is out there in the supply chain or at institutes. We also offer the opportunity for institutes and supply chain companies to come and give presentations on the work that they're doing. What we do is, in doing that, we also then try to put together some programs of work that might be cross-applicable to multiple SLCs. We also try to get some LFE, some learning from experience from the different SLCs to understand what work they've undertaken and how that might help us in the future. And so I've used lots of acronyms. I've just realised I've said SLC quite a lot, and probably I should explain that's a site licensing company. The site licensing company are the license umbrellas that are used to decommission all the various sites around the UK. So Sellafield Limited is a site licensing company, as in Doonray is a site licensing company, as in Magnox is as well. I think I've covered the first two slides in one go, I think. So just to tell you who our members are in the Waste Packaging Storage Working Group. They said the site licensing companies are DSRL, Research Sites, Magnox and Low Level Waste Repository, and now RWM. The regulators are the Environmental Agency, the Office of Nuclear Responsibility, and the Scottish Environmental Protection Agency. And we also have the NDA who sit with us. We also have the Ministry of Defence, Atomic Weapons Establishment and EDF, who all aren't actually site licensing companies, but have an interest, obviously, in nuclear materials and waste disposal. So that's pretty much the first two slides covered. One of the things we also do is obviously we support these PhDs, these PhD courses. Richard, do you want me to pass you on for the fourth slide?
Yeah, I can do. Okay, on the fourth slide then, where you start getting into topic areas, there are 5 topic areas that we've asked for proposals for PhD studies. So the 5 are technologies for waste package monitoring, performance of metal containers not made from stainless steel, methods of reducing the cost of waste packaging, methods for more efficient application of the waste hierarchy from the regulators, and development of alternative treatment technologies. So on the first one is slide 5 then, topic number 1. What I've said there is packages of what's called higher activity waste, essentially that's everything above low level waste, manufactured in advance of the availability of a disposal site, geological disposal facility, or manufactured for surface storage in Scotland, are going to require, are likely to require, long-term storage. One thing I do mention very briefly, even though the bias of this topic is on storage conditions, strictly speaking, even when waste packages are put to a geological disposal facility, they may well require further monitoring at that point. Although, in that context, I'm really only interested in the pre-disposal monitoring in terms of this particular topic. So monitoring of packaging integrity and aging processes is necessarily sought, mainly to confirm that packages are suitable for continued storage, and ideally if we can identify any observable aging trends to predict when or if we have to do any further work to the waste packages to maintain them in good condition. The existing high activity waste packages are currently made from metal containers such as stainless steel and ductile cast iron, or concrete containers, and for treating the waste internally, the current methods are mostly based on cement encapsulation, that's either infiltration or a form of in-drum mixing, super compaction processes combined with encapsulation, or for vitrification, mainly at the moment for high-level waste, that subset of higher activity waste. So we are interested in hearing about any potential studies that can assist with this particular area of monitoring waste packages. Okay, shall I move on to number 2? Topic number 2 on slide 6 is about improving the performance of metal containers not manufactured from stainless steel. Most of the higher activity waste containers we currently have in store are made using stainless steel containers, but potentially there might be an avenue for other metals to be used if our performance requirements can be met. Examples of non-stainless steel at the moment are ductile cast iron, which is just about to be used in the UK for some waste packaging. That really relies on thick sections and paint to provide the longevity, as opposed to stainless steel, which really relies on corrosion resistance, even in thin sections. Okay. On to slide 7, still part of the same topic. When selecting materials for containers, there have been option studies done by the industry. So there's a bit of a question about whether we can move away from stainless steel to cheapen the cost of manufacturing waste containers. For example, can we enhance the performance of other metals like carbon steels to meet our requirements at a lower cost? So any PhD studies that relate to methods of trying to improve the performance of other metal containers would be sought. Moving then on to slide 8. This one is topic 3 about reducing the cost of waste packaging as a whole. It would be fair to say the cost of manufacturing waste packages for higher activity waste is quite high at the moment, both in terms of the materials that are used, the fabrication costs of containers, and the methods of actually treating radioactive waste. Monitoring requirements during storage may also have a cost, yet to be fully determined. So there are questions about whether the cost of these packages could be reduced. For example, can we use new materials? Can we alter the fabrication methods for waste containers or waste treatment? Can we come up with modified monitoring requirements? So we'd be seeking any PhD studies in those very broad areas that may assist in reducing the cost of waste packaging processes and materials. Sean, can I hand you back for topic 4?
Of course you can. Topic 4 is really based around applying the waste hierarchy. Like many other industries, we would like, and it's highly desirable for us to apply the waste hierarchy for social acceptance and for basically moral reasons, as well as economic as well. Obviously, the waste hierarchy involves basically trying to utilize materials in the most effective way possible so as to reduce our waste that we generate. So the options tend to go in order of preference: waste prevention, waste minimization, reuse, recycling, and then disposal. Currently, what we tend to find in the nuclear industry is that things are really quite difficult to do as far as handling and processing is concerned. So we tend to take a relatively belt and braces attitude to most of the things we do. As a consequence, we are quite aware that we perhaps don't apply the waste hierarchy as efficiently as we may do at times. And so therefore this topic was really to try and get the academic community to help us in finding neat and simple solutions, or even maybe neat but complex solutions to dealing with our waste issues. So, for instance, and I use as an example here, I come from a material science background, so metallurgy and this sort of thing is very familiar to me. We've actually got many thousands of tons of stainless steel, copper, with many other things kicking around that basically often only has surface contamination, so it can be decontaminated or can be. And then the example I gave, actually, if you actually look at the actinides, which are such as uranium and plutonium, you actually find that once steels are melted, and if they've been surface contamination of uranium and plutonium, that uranium and plutonium will actually naturally sequester into the slag of the steel, and therefore, in theory, you could clean up the steel just by melting it in a traditional melting process and tapping off the slag, which will have all the uranium and plutonium in it. This was just an example that I used as a potential option. But as I said, there's other options such as decontamination. There's such as recycling of, say, lower activity waste. So, for instance, we have quite a large amount of very low active concrete on the site, which may be able to be reused in nuclear facilities to act as hardcore or whatever for roads. So we're just looking for people to kind of give us maybe some novel solutions to this. I mean, I've given you ones that we've already thought of, but some of these haven't been developed to a sufficient degree, or some of them, or there may be others that you can think of that may improve our use of materials. There's also the issue of sorting and segregation, which actually also falls into some of the decommissioning area. There was a tendency, in particular in the early stages of the nuclear industry, to mix waste up. So basically, there's some of the magnet sites, for instance, they have a waste called fuel element debris, which is largely low-level waste. But in between that, mixed in that is springs that are made of mnemonics. Now that mnemonics will become activated. So the mnemonic springs themselves are actually really high radiation emitters. So the fuel element debris has to, in its entirety, be classified as intermediate level waste currently. But if you could remove those springs, you could basically just convert the bulk of the waste, which is this magnesium alloy, you could basically convert that to a low-level waste and treat the two things in a more efficient and effective way. I think if we go on to the, if we go on to the next topic, or we on to, if we move on to the next topic, which is alternative waste treatment technologies. Now, as Richard has outlined, we spent an awful lot of time and effort and money in the 80s and 90s developing ways to cement up our operational wastes. And those projects were extremely successful and led to the construction of 4 plants at Sellafield and about another 3 or 4 around the country to immobilise intermediate level waste, or high active waste, as Richard called earlier on. Those were very, very successful, but we're now moving forward into dealing with some waste that are not necessarily amenable to cementation, and we're also trying to move forward and find and identify more effective and efficient ways of dealing with our waste. We're interested in other waste treatment options. In particular, there's some issues surrounding things like amphoteric metals such as uranium and aluminium, which will react with cement and cause corrosion issues. There's issues with oils and organic materials, which tend to retard the setting of a lot of cements. But also from a Sellafield perspective, not necessarily from the reactor sites, we have large volumes of waste. So anything that helps reduce volume of the waste packages that we generate will reduce the number of stores, will reduce the number of transfers of materials, and will ultimately lead to a reduction in the size of the repository when that's built. On the second page, I've talked about recycling already, so I thought I'd remove that actually from this slide and put it into the other one. But anyway, I won't talk about recycling. But we also have small volume waste. Some of these sites are starting to finally wrap up their operations and go into care and maintenance. Some of them are finding little, sequestered around the sites, little volumes of waste that aren't really large enough to justify building a processing facility dedicated to those wastes. So mobile facilities that allow us to go to various different sites and clean up wastes are opportunistic. But we also have things like mercuries and oils and just things like that are kicking around that have been used in pumps, mercury was used in switches, it's been used in laboratory equipment. All these sorts of small niche sort of waste are starting to give some of the sites headaches because they've got them kicking around. They're not really sure what to do with them. They've dealt with their major waste streams. They've just got these little bits and pieces lying around. So small, efficient waste treatment processes that can be turned into a mobile facility would be quite useful. Of course, what I put down here is the next option here is that, of course, whatever waste treatment process we do come up with, we need to verify the performance of the products and even the performance of the process. So there are even more novel waste treatment processes like vitrification and thermal processes, which are quite an advanced stage of development, but haven't been implemented in the nuclear industry because their products haven't been necessarily validated to the level that RWM would like. So there's issues like that we need to deal with. And just to go back to the original comment about sorting and segging, we do have a kind of quite a issue with some of our historic wastes that are quite mixed, and there's a reticence to try and characterise these wastes in significant detail, because that in itself will require workers to get in and take samples, which puts workers at risk of dose. It's costly, and it has many ramifications. So there's also quite a impetus to try and find processes that are as robust as possible to a wide range of wastes and that can deal with a mixture of wastes. So these are the sorts of areas that we've been looking at for alternative treatments, just to reduce cost and volume, increase robustness and insensitivity to input, and to tackle niche and problematic waste streams.
Lovely, thank you very much. Yes, thank you. So that's the end of our technical presentation. If anyone has any questions that they have, please either type away or visit. We actually have a couple of NNL people join us here. The facilities in their room, they weren't able to hear the audio. Do you guys have any questions? Also on the line, we've got Jenny Schofield and Matt Buckley from NDA, if anyone has any specific questions for them as well. I think we have a few people who have dialed in, so don't have the option to text. If you just want to ask your questions, please feel free. No questions? Has anyone got anything else that they feel could be anything they want to add to the presentation?
Actually, I will ask a question. I think it's on topic 1. Is it possible
to go back to the slide? Yes, sure.
Just on the general area of sort of monitoring and inspection, just really trying to get a bit more detail. Is the interest in sort of in situ monitoring within the store, ex situ in some sort of inspection cell? And my understanding is all waste streams are due to be analysed, and you look for what the likely degradation phenomena are. What are the sort of main things that need to be inspected? Is it the welds and the waste containers? Is it the dimensions of the waste containers?
Yeah, to try and answer it. I think it's partly defined by need, and I suspect also by practicality. I think typically the sort of things that get monitored or are being investigated at the moment are things like dimensional conformity that you mentioned, so looking at whether there's any dimensional changes, looking for any corrosion that may be occurring on the metallic containers, potentially also looking for measuring chloride deposition rates onto containers, because that can affect potentially the future corrosion performance of the container, or at least one of the factors. So that's typically what's been looked into thus far. Is that good enough to answer your question?
Yes, and just is there a desire to do this in situ within the waste store? Potentially using some sort of robotic device, or is it generally a case of retrieving the package and doing the measurement in an inspection cell?
I suspect that the waste producer would want to do it the most reliable and easiest way. Clearly, moving things out of store into an inspection cell, I would think, has some advantages in the sense that you can do a number of things in an inspection cell that you might not be able to do within an actual store itself with other packages surrounding them. But on the other hand, that does mean you have to lift them out and move them, and that does entail some level of risk in terms of lifting and moving operations. So I'm sure there'll be a trade-off along those lines.
Okay, thank you.
Okay. Richard, Zed.
Yeah.
I've just got a question on topic 1 as well about, this is all about monitoring the package. Is there any interest in situ monitoring within packages?
Potentially. I think if you looked at a waste form and you said there are known methods of aging and degradation, so if the development work for the project basically was saying we believe these waste forms can perform adequately, but we know that does rely on our original R&D being correct and remaining to be correct, if you like, then because there are degradation mechanisms that exist in waste forms, that could be a potential desirable but potentially very difficult challenge.
Yeah.
I mean, you may yourself have ideas on that. So.
No, that's fine. Obviously I'm thinking about the whole range of waste forms we may be producing in the future as well, as to other monitoring techniques we ought to be thinking about now.
Yeah. Yeah. Well, basically, I think if the characteristic of the package is required for safety reasons now or in the future, then and for handling purposes and other reasons, then there is potentially a driver to monitor it.
Okay, that's fine. Okay. Just do a question on number 5 as well. We've done work in the past on a little bit of work on polymers. Just looking at topic 5, is there still an interest in doing additional work on polymers, particularly the scale-up issues for the relatively niche waste materials?
I think that there almost definitely is. I mean, there will be a niche for polymers. I mean, I'm sure you're aware that there's still some work, as I understand, still going at Harwell on some of their polymer work. And certainly we have assessed it as an option for a number of different waste streams. It's just due to prioritisation and resourcing, they've tended to fall a little bit off the radar a little bit. But that in itself is an opportunity, isn't it, to develop polymers to a higher degree to make them more acceptable for when those waste streams get treated. So yes, basically.
Right.
I could add something to that I mean, there's already one very minor niche stream that's already polymer encapsulated because of the benefits the polymer gives to that particular waste. And historically, it's certainly been a much bigger waste stream at one of the power stations that has used the polymer encapsulation.
Yeah. No, just we've kind of toyed with doing more work on polymers, but have yet to actually start any sort of PhD topics up on it.
Okay.
Any more questions?
I have a question.
Yes.
I think it was topic 4. So you mentioned an example of decontamination of steels through smelting. I'm interested to know how that technology has been developed and what those answer questions.
I think there is. I mean, sadly, it's a little bit of a topic that's gone around the houses in the nuclear industry, both in America and in Japan, and even here in the UK. We undertook an awful lot of work on smelting in the 80s. I think the requirement is still seen as slightly in the future. Obviously, now as we're heading to large scale, sometime in the next decade, we're going to be starting hitting broad front decommissioning at some of the plants at Sellafield. So somewhere in the sort of mid-20s, later, we're going to hit broad front decommissioning. I think this is where, in some ways, the development that was done before was a bit ahead of its time. In fact, a lot of it was done for Capenhurst at the time, which was a real need. I think the work was done and then we kind of put it on the shelf a bit. But people have even gone to the level across Europe and in America of looking at how, if this comes about, they may even be able to justify building a steel mill to mill the steels from, particularly the US, where the volume is so large.
Okay.
And they say basically, and if they couldn't decontaminate the steels to a significant level as to pre-release the steel into the commercial market, they can at least recycle it as low-level waste and make ILW, intermediate level waste containers out of it, and things like this. So this has gone through this has been masticated on plenty of times. But what I can see from the PCM side and the plutonium contamination today, it's largely been ignored actually. This is why I kind of brought it up. It seems to be an area that lends itself almost perfectly to this because of the thermodynamics. The thermodynamics are such that basically the plutonium and uranium will go to the slag.
Okay.
I know in Japan they've looked at it. They use uranium analogues. I think whether that's because uranium was the subject at hand, or whether the step up to plutonium is such a big step that they just used uranium because it was easy to use as an analog for plutonium. I don't know, but certainly people have looked at it, but no one I think has applied it.
Right. I'm just interested if there's any interest in the NDA in looking at kind of the modelling of migration of actinides through during this process.
I think that will have to happen eventually, if not before. So, because the thermodynamics you can model, and kinetics you can get some models for, so I don't see why that wouldn't be it. Okay, would be possible.
Is that all the questions now? Has anyone got any more they want to add, or anything else that they want to add before we conclude the webinar? No? Okay. Well, thank you very much, Richard and Sean, for your presentation today. It's very useful. The webinar will be displayed on the website once it's been edited. Well, thank you all for your time, and we'll speak soon.
Okay, thank you.
Thank you very much, Richard.
Cheers then.
Right. Thanks, guys.
Bye.